Alright, picking up where we left off with domain and range, functions and relations. So example 3 here, we want to use the vertical line test to determine if each relation is a function. So again, what you want to do is you want to draw a vertical line somewhere through your function, okay, and see if it crosses, see if there's anywhere that it'll cross more than one time. So for the first one, if I draw a vertical line here, right, it crosses our function, our relation, at 2 different points, which means graph A is not a function. Okay. On part B, if we draw a vertical line here, it only crosses once. We draw a vertical line here, it only crosses once, right? That's fine. That means it is a function. As long as there's nowhere where a vertical line will cross twice, then we have a function. Okay? So this is indeed a function. From what we know from graphing and whatnot that we've done in class, this is a specific type of function. This graph, this curve, right, is exponential. So this is actually an exponential function. I know that without even having to see the function itself. And that's going to be some number to a power. Alright? Good. Now let's talk domain and range. Alright, so let's talk about this. It's a word problem. Okay, domain and range in a word problem usually means you're going to have some sort of restricted domain. Okay, what I mean by that is it can't just be a bunch of random numbers. It's going to have to be something pretty specific. So, Omar has decided to take a yoga class for 1 year. The yoga studio costs $10 to join, and then each yoga class is $5. Omar's fees can be represented by the function given here. That's important. Okay, what are the domain and range of the function? So, we're going to assume here that he's taking 1 class per day, and he's going to do that for an entire year. Okay, if that's the case, then, we want to show that domain. So the first domain would be, if he didn't take any classes, right? He's going to join the studio, but then he doesn't take any classes, right? So X is the number of classes. X is the number of classes he's going to take, and Y is going to be his cost, right? So this is your domain. Those are the inputs, and these are your outputs, right? This is the range. And here's how we write it. So the domain is going to be, you do a bracket, okay? And the domain is going to be, I'm sorry, not a bracket. I didn't draw a bracket very well. It's a little squiggly line deal. So first option is he doesn't take any classes. Well, let's go ahead and do the range that goes with each of these. If he doesn't take any classes, what's it going to cost him? It's going to cost him $10 because he already joined the studio. Okay. The next number of classes that he could take after that would be what? Can you take a half of a class or a third of a class? No, you have to take a whole class, right? So he's got 1 here. And then if he does that, how much will he have paid? So it's $5 per class. So the next output is going to be 15. Okay. Well, what if he takes 2 classes? Then the output would be 20. So our range values are limited to every 5, and our X values, our domain values, are counting by 1s. And you can't have it in between because you can't take 2.5 classes or anything like that. Now, he can take 1 class per day for a whole year. So this domain is going to keep going until we get to, right? Because there's 365 days in a year. Now, you may say, well, how am I supposed to figure out, what the Y values would be there? Well, it's easy. You have a function, right? So if you plug in 364, okay, if you plug in 364 into that, you get 5 times 364 plus 10, which comes out to be 1,830. Okay? And then if we do the full 3, if we do 1 every day for the whole year, 1 class per day, then 365 plugged into that gives me, well, we know we're counting by 5, so it should be 1,835. Okay, that's what's called a restricted domain. It's limited to very specific values. And if you were graphing this, you would be graphing a bunch of points, a bunch of dots, because it wouldn't make a whole lot of sense for you to draw that line in between. Because why? Because you can't have half of a class. Okay, So if you're graphing it, you could draw the line, but the points, each individual point is what would really matter. Okay? All right, so we got one more example to look at. And we want to identify the domain and range given a function with no context. There's no word problem to be associated with this. So when I look at this, when I talk about the domain, I am talking about the x values. I'm talking about everything moving in this direction, left and right. So I have two questions for you. First one, does this graph ever stop moving to the left? You see this arrow right here? It tells you that it keeps going to the left. It doesn't ever stop moving to the left. Okay? So it doesn't stop at -10, doesn't stop at -20, doesn't stop at -30. It keeps going on and on into the negatives forever and ever. As Buzz Lightyear would say, to infinity and beyond. Right? In this case, negative infinity. Okay? Now, on the other side, we're going up, right? But we're also moving to the right. And just because my graph stops here, do you think that means that the graph is going to stop moving to the right? No, it's going to be going up really far, really fast, but it's also slowly pushing to the right as well. And it will continue to do that to positive infinity, right? Think about your number line. Negative infinity over here, positive infinity over here. So that domain is negative infinity to positive infinity, which can also be called all real numbers. Those mean the same thing. Okay? Now, the next thing I want to talk about is the range. So, the range is how far this graph goes up and down. Okay? Well, we just talked about the fact that it goes up forever and ever, right? It takes off the top of this graph, and it's just going to keep going in that direction. Again, we're going up, so we have a y value that goes eventually to positive infinity, right? It just keeps going forever and ever. So we know that this graph is going to go to positive infinity on the range. The place we have a trick at, or the difference, is if we look at how far down it will go. Okay, if we look at the depth that it's going to go to. Well, as I follow this graph back down, it's doing what? It starts to level off. Okay, it's reaching a point where it doesn't go any lower. Okay, and you want to write down where that's approaching. So we talked about being exponential, right? So if we were to write our t-chart for this up here, you would have 2 to the first is 2, then 4, then you're squaring all that kind of stuff. What if we went the other way? We talked about a half, a fourth, an 8, 1/16, talking about fractions. It's always 1 over some larger denominator, right? The numerator is always 1. The denominator keeps getting bigger and bigger. So that means it's getting closer and closer to 0, okay? But if it's always 1 over some giant number, then it's never actually going to equal 0. It just keeps getting closer and closer, right? And it keeps doing that to infinity, right, to the left. So the lowest it ever goes, the lowest it ever reaches, is that it approaches 0. Okay, we always go from bottom to top. So it goes from 0 up to positive infinity. Okay? So that is your range, from 0 to positive infinity. All right? And we'll do some more examples with that as we go forward. You will notice that anytime we can include 0, like it stops specifically at 0, then you can sometimes have this kind of bracket, which means that the number is included, right? This would mean that you include 0, right? You're including that specific number, kind of like the open circle, closed circle type thing. This up here is saying that we can't really include 0 because it doesn't ever actually hit 0. It just gets really, really close to it. All right, so make sure you know the difference between the parentheses versus the bracket symbol. All right. Again, our answer is not that. So our answer is this for range, and this or this for domain. Okay? You can only use all real numbers if it's negative infinity to infinity. All right? So get to work on 313, and the videos and stuff for 314 will be coming up soon.